Good evening, Tushar sir.
Good evening, sir. Sir, still I'm not able to share the screen.
Why? Take just a second. Give me a second. I'll make you host again. You are co-host now. Just a second.
Yes, now I'm.
Can you try it now?
Yes, sir. Yes, sir. Now I'm able to.
So, welcome to Tushar sir once again, and dear learners. Sir, now you can start your session, sir.
Okay. Thank you, sir.
Yes.
So, good evening, learners. Just give me a second. I'm going to share my screen. I hope my screen is visible to everyone.
Yes, sir.
So, learners, today we have to start the unit number 12, that is advanced topic in C++. Okay, till now we have completed 11 unit and we have learned so many concepts in C++. Now this will be the last topic, I think, that is advanced topic in C++. After that we have to see some project related work. Okay. So now let us start this unit. What we have to understand in this. So the objective of today's session is to understand namespaces, dynamic polymorphism, and with the smart pointers, and what is the concept of multi-threading in C++ that we have to learn today. Okay, so let us start with this. First we see the namespaces. What does it mean? So till now we have used one namespace, that is std. So what actually it means we have to learn. So in C++, namespace is a collection of related names or identifiers. Okay, we know that what are the identifiers in C++, whether it may be a functions, a class, or a variables, or any other any other result keyword that you use. It's the identifier, right? So it is a collection of related names or identifiers which help to separate these identifiers from similar identifiers. Means, let's say if you are using we know that if you have used one keyword, okay, let's say, or for example, let's look the following code. In the main function, let's say if we declared one variable with the name var, so this var is the identifier because it uniquely identifies this variable. Okay, so if you declare or if you use any identifier in any function or in your class, then you cannot use it with the same name. Suppose let's say if you want to declare this once again, then you cannot do that, right? So your namespace helps to separate these identifiers if you want to use the similar name for your identifier. Okay, so that we are saying over here, that which helps to separate these identifiers from the similar identifier in other namespaces or the global namespace. We'll see what is mean, what does it mean. Okay, so let's say in the main function, if you want to declare a two variable with the same name, then definitely you cannot do that because it says that you cannot declare this within the same scope. Okay, and it is called as the conflict, naming conflict. Okay, so to overcome this we have to use the namespaces. We know that this code doesn't compile successfully because we have declared two variables of the same name where within the scope of the main function. Okay, so we have declared these two variables in the main function, so we cannot do that. If you want to do that, then either we have to put it into a different namespaces or we have to change the scope. Okay, so in C++, this is known as naming conflict. When you are using two variables or two name, then it will be the conflict. Okay, your compiler does not understand that which it has to use, right? So therefore, it will not allow us. So one way to compile the code without error is to declare one var in another scope separate from the other var. So this is the one way that you can declare two variables with the same name into different scopes. Okay, if you are using one in the one function, then you can use it in the another function. So their scope will be changed and there will be definitely no problem. You can successfully compile that code, right? Let's say, for example, in the main function, we have created one variable with the name var and we have declared it globally. Okay, means its scope is within this main function. After that, we have created another scope by using this curly bracket, opening and curly uh, bracket. We have created one block over here. And in that block, if you are declaring any variable with the same name, so there will not be any problem because the scope for these two variables are different. The scope for my first variable is the main function, and scope for this second variable is this block. So there will not be any problem. Okay. However, we can use the same name for multiple variables inside the same scope if we use the namespace. It means that you can declare two variables, or you can use two variables with the same name, but that should be possible only if you are using the namespaces. Okay, this is the one way if you change the scope, and second way is your namespaces. If you are declaring those in the namespace, different namespaces, then you can definitely use them within the same scope. Okay. So in other words, namespaces in C++ are way to prevent naming conflict. Okay, it prevents from the naming conflict within the program, and especially if it is a large project. So to avoid the naming conflict, we have to use the namespaces. Now we have to see that how can we create a namespace. So for this, we can create a namespace by using the namespace keyword. Okay, for this we have to use the namespace keyword and declaring or defining other entities within its scope. So now let's take that how can we do, or how can we create a namespace. For this we have to use this namespace keyword. After that we have to provide the name for this namespace. Let's say for example here we are creating DBL. So DBL is the name for this namespace, and we are declaring one variable with the name var within this scope. Okay, so it means that now this DBL namespace is having one variable with the name var, right? Here we have created namespace named DBL and declared double variable named var inside it. Now we can use the scope resolution operator. We know that this double colon is called as the scope resolution operator outside the namespace to specify that we are using the var variable belonging to double DBL. Okay. So if whatever you declared or defined within this namespace and you want to use them in your program, then we can do that by using this name DBL. After that, we have to put the scope resolution operator, and followed by you can provide the entity that you want to use. For example, if you want to use variable, then you can use this. Okay. For example, let's say DBL scope resolution operator and var. So this specifies that this var belongs to this DBL namespace. Because we have used this scope resolution operator, it means that your compiler will come to know that this DBL is what? It is the namespace. Already we have used std namespace in our program, where we have put std colon colon cout, std colon colon another function we have used from, right? So similarly, we can create a namespace like this syntax. For this, we have to just put the namespace keyword followed by namespace name, and you have to provide the opening and closing curly bracket, and now you can define any variable, any function, or anything within this. Okay, even class also. So if you want to use them, then just you have to put first DBL, after that colon, double colon, means scope resolution operator, and then the entity that you want to use. Okay. For example, let's say here we have created one program where we have included IOStream, we have included std. Now we are creating one namespace over here with the name DBL, and in that we are just declaring one variable var. Now inside the main, we can declare, now first we have created one variable integer type of var equal to 5. Okay, so this is my normal variable. Again, we want to use the same name for another variable, so we can do like this. So you can use DBL scope resolution operator, then var equal to 5.55. So now here in the same scope, means in the main function, the scope for these two variables are same. That is the main function. So within the same scope, we can now define these two variables with the same name, but it will not give you any error because this var belongs to this DBL namespace, and this is our normal variable. Okay, so it will not give you any error. If you compile this program, then successfully it will be compiled, and you can check that. Let us switch to the compiler. So here we have created two variables within the same scope, var is equal to 5 and var is equal to 5.5, and just we have printed it. Okay, if we execute this, then you will get the output that dbl var is equal to 5.55 and main var is equal to 5. So there will not be any naming conflict, right? Why? Because we have used the one variable which belongs to the namespace. So for this, to avoid the naming conflict, we have to put it into a namespace. moving ahead, we can use multiple and nested namespaces also. Means we can use multiple namespace in a single program. Okay. Yes, we can use the multiple namespaces in a single program. Okay, multiple namespaces are especially useful when writing a large program with many lines of code. So if you are working on the large project where you have to use the same name for the different variables or functions or classes, then you can separate them by using the namespaces. Okay. So similarly, namespaces can be nested also. Means you can create a namespace within another namespace. Okay. So within another namespaces, it allows us to structure our code in a logical and hierarchical manner. For example, let's say here we have created one namespace one. Okay, so one is the name for this namespace where we have created one function named as display, which will just display the or print something like namespace one. Okay. Now within this namespace, we are creating another namespace over here whose name will be one underscore one. Okay. So now we are nesting the namespaces. My outer namespace is one and my inner namespace is one underscore one. And in this function also, or in this namespace also, we have the same function with the same name, that is display. Okay. Our aim is what? Our aim is to use the identifier with the same name, multiple identifier with the same name by using the namespace. But we are separating them by using, either you can put them in the different namespaces or you can use the nested namespace. Okay. So here also we have created the function display in the nested namespace. After that, there is another namespace, that is a namespace 2, which is outside of your first namespace. Okay. See here, my outer namespace, that is 1, now ended over here. Okay. So this namespace 1 is ended over here. Now I am creating another namespace with the name 2, and in which also we have one function with the same name, that is the display. Okay, and which will print namespace 2. Okay, this namespace is also ended over here. And at last, again, we are having the display function, which is outside of any namespace. It is not included in the namespace 1, neither in the namespace 1 underscore 1, and nor in the namespace 2 1. So it is outside, or it is a globally we have created one function, that is the display. So now we are having display function 4 times. One is in namespace 1, another one is in namespace 1 underscore 1, third one is in the namespace 2, and fourth one is in the display function. Okay, sorry, in the main or outside of any namespace. Let us just copy this program. So we'll have clear picture in one screen. And at last is there will be a main. We'll copy this main function also and paste it over here. Now let us try to understand what we did in this. So here first we have created one namespace which started from here to here as highlighted. Here you can see that within this namespace 1 there is one function named as display, and there is one another namespace within this outer namespace and whose name is 1 underscore 1, and in that namespace also we have included one display function. After this we have created second namespace, that is the display namespace 2, and in which also we have included the display function. Okay, and at last we have created one display function outside of these two main namespaces. First one is the 1 and second one is the 2. Okay, so it is outside of any namespace. Now after that we have created the main function, and in that main function now we are calling the display function by using the namespace. Okay, so as we know that if you want to call the function, then we have to first access it by using the namespace name. So we have included one scope resolution operator and display. So what it will execute? When compiler comes to execute this function, then it first take this namespace named as 1, and in that it will search for this display function. So definitely within this one namespace we are having this display function, so it will execute this one. If we try to execute, then see here the first statement that it has executed is the namespace 1. It means that this display function has been invoked and it has printed the namespace 1. Okay. Followed by we have executed the one scope resolution operator. After that, 1_1. After that, again scope resolution operator and display function. So now your compiler come to know that first it will check this namespace. Within that, it will check this another namespace, and within that, it will check this display function. So we are also having the same structure in the namespace. First, it will search for this namespace. Within that, it will search for the 1_1, and within that, it will find this display function. So definitely, it will print that namespace 1_1. So here also we have can check that the output is namespace 1_1. Similarly, for the third one also, now this two and scope resolution operator display, it will invoke the display function which belongs to this namespace 2. So it will print namespace 2. And at last, we have just called the display function without using any namespace name. So definitely it will not check any of the namespace, neither this one nor this two. Instead, it will check outside globally that is there any function with the name display. So it finds this display function and it will execute. Okay. So if you execute this, then you can separate the name, or um, you can use the multiple functions with the same name, but you can separate them by using the namespaces, as like we have shown in this program. Okay. Now moving ahead, using the directives. So we know that we can bypass this scope resolution operator with the help of using directive. Initially in the earlier programs also we have included std namespace, and if we don't want to use this std again and again in our program, then we have used the directory. Okay, using namespace and namespace name. So likewise we can use these namespaces, or you can use this using directive for these namespaces also. Okay, so in fact we have been using this directive for the majority of our programs so far with the using namespace std code. By including the using namespace std code in our program, we can omit these multiple times, or we can omit this part for the identifiers defined in the std namespace. So if you declare this at the outside of your program, in this program also we have used this namespace, as you can see over here, using namespace std. So you don't have to use every time std like this, std colon colon cout. Here also you cannot use std colon colon cout. Otherwise, if you don't use this, if you comment this, then you have to use this syntax std colon colon cout, std colon colon cout, everywhere wherever you want to use the cout or cin function or any other function which belongs to the namespace std, right? So you can use these using directives for this user defined namespaces also. Okay. For example, let's say this is my program where we have included the library using namespace std. Then we have created one namespace one in which there is one function named as display. There is another namespace whose name is namespace 2, and here also we are having one function with the name display. Okay. Now in the main function, if you are using like this, using namespace 1 or using namespace 2, so to call the function which belongs to this namespace, before that you don't have to write the namespace name. So here also you don't have to write one, then scope resolution operator, and then display. You can directly call this function like this. Why? Because we have already included this namespace in our program. So your display function or the visibility of this function will be global now. Okay, so to make it global, you can use this syntax like this. For example, let's say we'll try to execute this, or let us understand that in our earlier program, can we use this in the main function? So let's say I want to call this display function, and from the namespace 1, okay, from the namespace 1, and if I am writing like this, using namespace 1 over here, okay, so if I omit this one, so will it execute? Will it execute? Is there any guess? Can you tell me? Anyone can guess that if I
Yes, it can execute, sir.
sorry,
It can execute.
it will execute. You will say that it will execute because we have included this using namespace 1. So my
Yes, sir.
display function which belongs to this one namespace, it will execute, right? You want to say that, okay? But I think that it will not execute. Why?
Right, sir.
Because why? Because now even though you have used this using namespace one, okay, so it means that whatever the entities you have included within that namespace, that will be visible globally. And already globally there is one display function, as you can see over here. This display function will not be is not belong to any namespace, and its scope is global, right? So it means that now if you are including this, so you are creating the or you are changing the scope of display function which belongs to the namespace one is global. So now there will be two function with the same name and in the same scope. So that will be not allowed in C++. You will get the this error that call of overload display is ambiguous because your compiler don't doesn't understand that which display function it has to invoke, right? Because there is already one display function, and by using this syntax you make this display function globally, right? So therefore it will be the ambiguous situation. So every time when you use the namespace, you have to keep in mind that is there any already globally declared that entity. Okay. So if it is, then it will not work. In another case, now see this program here. Now I'll copy this program. Now in this program, we have two separate namespaces. That is one and second one is two. And in these two namespaces, there are display functions. So now if we try this main function, if we try this main function where we are including this namespace one, so it means that the display function which belongs to this one namespace becomes global, means it will not consider this part. Instead, it will become like this. Okay, naked display function, which is outside of your namespace one, right? So now if you now it is global, so you can directly call like this. Okay, but again it will check that whether there is any display function which is globally declared. Okay. So now in this case it will work. Definitely it will work. But let's see if you are writing any function over here which is already global like this, then definitely it will not work because this will also become a global scope and this function is also in the global scope. So there will not be chance that you cannot declare the same function with the same name in the same scope. Okay. So here it will give you error that function does not name type. Did you mean union or etc. Okay. So you cannot display, you cannot create like this. But definitely, if there is no any function, then if you are using this namespace one, then this display function will be invoked, which belongs to this namespace one. So as you can see that if we execute this, then the first display function which belongs to the or invoked that belongs to this namespace one, and second one, if you want to call, then you can call like this, right? Again, if you include using namespace two over here, so now again there will be problem because let's say if you want to call like this, then what will happen again is display function which belongs to one becomes global, display function which belongs to two again become global. So it means that that will be considered that you are declaring two functions with the same name with the same scope, right? So again it will give you error. So every time when you are using the namespace and calling the functions or any accessing any variables or class, then in that case, every time you have to make sure that there will not be any ambiguous situation. Okay. So I hope you are having the clear understanding of this concept that how can we use the namespace and how can we call the namespace functions or any entity.
I have one doubt. Can we go back to the previous program?
Program. Yes. Yes.
So if we give braces between the line number 19 and 20, and if we write using namespace 2 over here, will it still throw
Yes,
the error?
definitely. No, 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 because you are changing the scope.
Okay.
Let's say 19 and 20 right over here, right? So if you are using this scope and you are using namespace 2, right? Like this, now.
Yeah, and now I'm calling the display function.
Okay. So I am also having some doubt over here. Let us take. No, will not work. Again, it is not allowed that because this will also because we are calling the function over here, right? And when we are calling, you can declare within the different scope, but calling is not allowed. I think. Okay.
Okay.
That clears me also. Thank you. Okay. So
Okay, got it.
yes. So let us go to the slide. Okay. So now moving ahead. So I hope you are having a clear understanding of this concept that is the namespaces. Now we'll move ahead and
Yes,
we
sir.
have to see the another concept that is the dynamic polymorphism. Till now, we have learned the polymorphism concept in our earlier sessions. What is meant by polymorphism, where we can declare means there are two kinds of polymorphism. One is compile time, and second one is the runtime polymorphism. Just recap the concept that what is meant by polymorphism. So we know that there are two types of polymorphism. One is compile time, and second one is the runtime polymorphism. And compile time polymorphism says that you can create multiple functions with the same name, but they must have the different parameter list. Okay, so it means that suppose you are using the three display functions, then there must be change in these three display function in case of their parameters. Okay, and the parameters also we can change in case of number of parameters, then type of parameters, and then third one is the sequence of parameters. If you remember, okay, number of parameters, type of parameters, and sequence of parameters. So by changing this parameter list, we can create multiple functions with the same name in a single class. So that is called as the compile time polymorphism. Second one concept we have seen the runtime polymorphism, where we have used that concept in the inheritance concept, where if your base class is having one function in your base class, so that you can redefine within your derived class. But for this also, you have to declare that function as a virtual in your base class, and if you want to call that function or redefine that function, then you have to override that function in the derived class. Okay, and you can call that function by using the or by creating the reference object of your base class or the base pointer of your base class, and you can define or you can assign any object to that base pointer, and then according to that you can call the function. Okay, so just keep in mind that. So polymorphism allows objects of different derived classes to be treated as object of common base class, typically through the base class pointers or the references. We have seen in the inheritance that if we create the base class pointer and then if we are going to assign the derived class object to it, then definitely by using that object or using that pointer, if you are trying to call that function, then it will call the derived class function, right? If you are assigning the base class object to it, then it will call the base class function. Let us take one example. It has already seen in our earlier program also. Let's say we are having one class named as shape. Okay, so here we have created one class that is shape, within which there is one function that is virtual. We have declared this as a virtual. Void is a return type of that function. Draw is the name of the function, and after that we are printing something that drawing the generic shape. Okay, so this function belongs to the shape class. This class is having one destructor also, shape. Okay, and it is the destructor. Always make base destructor virtual. So therefore we have declared this as a virtual. After that we have created one another class named as circle, and in that we are inheriting this shape class. Okay, it means that whatever class we have created first, that will be work as a base class, and from this class we are inheriting this shape class in this circle class. Okay, now in this circle class, we are again redefining this draw method. So at this time, we don't have to use virtual because we are redefining it. So the name of that function will be same. And after that, we have to use one keyword that is the override. It means that we are saying to the compiler that we are overriding this function, which is already available in my base class. Okay. And in that, you can change or you can do whatever you want. Here we are just printing something that drawing circle. Now it means that there is one base class named as shape and which is having one draw function, and in the circle class in which we have
Sir,
inherited the
once
shape
again you
class.
can explain, sir.
Sorry.
Once again you can explain, sir.
Yes, yes, definitely. So let's focus over here that we are having one class named as shape, right? And in this shape class, we are having one function that is draw function. Okay, name of that function is draw. Return type of that function is void because it is not going to return any value. So therefore, the return type of that function is void. And because we want to redefine this function in the derived classes, so therefore we have declared this as a virtual. So what virtual says, whatever function you are declaring as a virtual, so from this class, if you are creating any new class, then you can redefine this draw function in that derived classes. Okay, getting my point? So this is the class shape which is having one function draw and which is virtual. It means that it can be override in your derived class. That's now we have created another class named as circle, and we are inheriting this shape class in that circle class. Okay, it means that all the functions which are available in the shape class will be available in the circle class by default because we are using inheritance concept. But now in this circle class we want to redefine this draw function, so therefore we have again redefining this function like this. Here we have to use just the return type, after that the name of your function, and its return type, or sorry, its parameter list also be same or should be same as like your base class function. So in the base class function there will be there is not any parameter. So here also we are not using any parameter in the parameter list. But after this function we must have to use this override keyword, which says that you are redefining this function and it is already available in your base class. Now in this function, if in the base class function, if you are doing something, so you can change the work whatever you have already done in this. Okay, so you can change. So definitely we are printing something different which is not like your base class. In the base class we are printing drawing generic shape, and here we are printing drawing a circle. Okay, so just we are redefining this. Redefining means what? Writing that function again in your derived class. Okay, and if you want to change the content, then you can change in that function. Okay, so in this function, in the base class function, we are printing something different, and in the derived class function we are printing something different. Okay, again we have created one third class. Okay, so now here also we have created the square class, in which also we are inheriting the shape class. Shape class means your base class, this one class. Okay, so it means that now from this shape class we have created the two classes. One is circle and second one is the square, in which also we are inheriting the shape class, and in this class also we are redefining this function. Because this draw function is declared as a virtual, so whatever classes you are creating or you are newly creating from this shape class, in each that derived classes you can redefine this function, draw function. Okay, again we are using the override keyword over here, which specifies that you are overriding means you are redefining that function, and here we are changing the content, that is we are printing drawing the square, right? Now inside the main function, what we did, we have created the base class pointer over here. See here, this is the asterisk sign which specifies that it is a pointer, and what type of pointer it is. So we are creating the shape type of pointer. Shape is what? Base class. So therefore it is called as base class pointer, and this shape one is what? It is the name of your object. Okay, so here we are creating the base class pointer whose name is shape1, and you are assigning the reference of this circle class, because see here we have used the shape class. Here we have used the shape class, but at the left hand side, at the right hand side, at the left hand side you have used the shape class, but at the right hand side you are using the circle class. So it means that we have created the base class pointer whose name is shape1, and you are assigning the reference of your derived class circle. So what will happen now? This shape1 will hold the reference of your circle class. Okay, and by using the new keyword we are creating or we are allocating the memory to our base class pointer. Okay, similarly we have created another base class pointer named as 2, and at this time we are assigning the reference of our square class. So now there are two base class pointer, shape1 and shape2. One is holding the reference of circle class, another one is holding the reference of square class. Now by using this base class pointer, if you are calling the draw method, okay, now this shape1 is the base class pointer, but now it is holding the reference of your circle class, right? So when you try to call any function, or let's say draw function, by using this base class pointer shape1, so it will definitely first check that whose reference it is currently holding. So now it comes to know that my shape1 base class pointer is having the reference of circle class, so that will definitely call the draw method from the circle class. So now it will call this draw method, second this draw method, and it will bring the drawing the circle. Okay. Similarly, if you are using the shape2 base class pointer and you will call this draw method, then first it will check that in the shape2 base class pointer whose reference it is currently holding. So it comes to know that, okay, in shape2 there is a reference of square class. So when you call this draw method, then it goes to that square class and it will execute that draw function which belongs to the square class. Okay. Now once the task has been done, then we have to manually call this delete keyword, or we have to manually release the memory which is occupied by this base class pointer. Okay, because we have already learned the concept of base pointer, okay, base class pointer, that whenever we will use any base class pointer and assign some reference to the reference of a class to that pointer, then we have to manually freeze up the memory which is occupied by these base class pointers. So therefore, to release the memory, we have to use this delete keyword. So here we are, after the task has been done, so we are calling this delete shape1, so it will remove the memory which will occupied by this shape1. Similarly, we are calling the delete shape2, so it will release the memory which is occupied by the shape2. Okay, this is the program that we have already seen in the inheritance concept. Okay, so this is just a revision of that program to understand that how we can use the concept of polymorphism in the inheritance. So it is the runtime polymorphism. Okay, it is the runtime polymorphism. Okay, where it will check that whose reference it is currently holding, and based on that it will call the function. Okay, now we have to see the concept of smart pointers, or first we have to take the explanation. The base class pointer shape refers to the derived object circle and square, and the appropriate draw executes dynamically at runtime, right? But the problem in that program is what? We have to manually manage the memory. We have to manually manage the memory. So here, if you are using this new keyword, it means that you are manually assigning the memory to the shape1. Here also you are using the new keyword, then it means that you are manually assigning the memory, allocating the memory to the shape2 also. And once the task has been done, then you have to release the memory also by using this delete keyword. So this is the manual task. Okay. So in the above code, we have to use, or we use the new keyword and delete keyword manually to allocate the memory and to release the memory also. If an exception occurs or we forget to delete, then we get the memory leak. That is the problem with this code, that if we use this polymorphism concept in inheritance by using the base class pointer concept, then in that case we have to first manually assign the memory, manually release the memory, and in between, if any exception occurs or if we forget to delete, then we get the memory leak. Okay, so to overcome these problems, we have to use the concept of smart pointer. So that's where we have to use the smart pointer. Okay, now these smart pointers, about these smart pointers, let us understand. These smart pointers are RAII. RAII means what? Resource acquisition is initialization. Resource acquisition is initialization. Or in simple term, what it means, whenever you are using, or if you are creating any RAII object or pointer, then it will automatically allocate the memory. And if your object which occupies that memory goes beyond the scope, then automatically it will release the memory also. So you don't have to take the overhead of memory management if you are using the smart pointer. So that is the main advantage of using the smart pointers over the raw pointers. Earlier we have used the raw pointers where we have to use the new keyword and manually delete the memory. But when you are using smart pointers, then we don't have to use the new keyword also. We don't have to release the memory manually also, right? So it is actually work as a wrapper around the raw pointer. Okay, means we have wrapped the raw pointer within these smart pointers. Okay, so they automatically manage the memory. When the smart pointer goes out of scope, the object is automatically destroyed, and the memory which occupied by that object, it will also release automatically. Okay. So now we have to understand there are three main smart pointers. One is your unique pointer, second one is the shared pointer, and third one is the big pointer. So now we have to understand these three types of smart pointers. Okay. Here some key features is given that when you use the unique pointer, then it has a exclusive ownership. We will explain this. What does it mean? In the shared pointer, it has the shared ownership, and in the weak pointer, there will not be any ownership. So it is a non-owning reference to a shared resource. Let us understand one by one. First, we'll see the unique pointer. So in C++, this unique pointer also belongs to your standard library, okay, standard namespace. Okay, so it is a smart pointer that provides exclusive ownership of dynamically allocated object. Okay, now exclusive ownership means what? If your object or if your smart pointer is working on some resources, okay, that resources may be your function, that resources may be any class, that resource may be any file, that resource may be anything. So if your smart pointer is using any resources, then it will have the ownership of that resource. Okay, therefore it is called as, or that smart pointer is have a will have a complete ownership of that resource. Okay, exclusively means fully. Okay, so if your smart pointer is occupied or working on a resource, then it has the ownership of that resource. Only one unique pointer can own a given object at a given time. It means that if you are having a multiple smart pointer and they are trying to access the same resource, so in that case, only a single smart pointer will have the complete ownership of that resource. So if that unique pointer will occupy that resources, then no other smart pointer will occupy that resource till the task has been complete for the first pointer. Okay, so only one unique pointer can own the given object at a time. So when unique pointer goes out of scope, it automatically deletes the managed object. It means that if that unique pointer or the smart pointer goes out of the scope, whether it may be the task has been done or it goes to the end of your program, then after that your first pointer is destroyed, and then the other pointers can occupy that resource. So if till the first pointer occupy the resources, then no other pointer can occupy that same resource. So that is the main advantage of smart pointer. Okay, so when the unique pointer goes out of scope, it automatically deletes the managed object, means whatever the object it has occupied, that will be deleted. Okay, now how can we create the unique pointer? That we have to understand. So as we said that we have already seen that this unique pointer belongs to this standard library. So to access this unique pointer, we have to use this std unique pointer. Okay. Std unique scope resolution operator, then unique ptr, and followed by you have to provide the type of that unique pointer. Okay, and basically this complete syntax is the syntax of your class template. We have already learned the class template, function template. Just revise that once, then you come to know that this is the syntax of your class template. Okay, so here to create the unique pointer, first we have to use the standard, after that scope resolution operator, then followed by the type of that pointer and the name of that pointer. So this syntax, this left hand side syntax is used to declare the smart pointer, and this p1 is the name for that smart pointer. But it is just declared, but to initialize it like a new keyword, here in the smart pointer concept, we don't have to use the new keyword. Instead, we can directly use the function template over here. Left hand side, we have to use the class template, and the right hand side, we have to use the function template. So the function template name is make unique. So that will allocate the memory to this p1, and it will create that object, because as you can see at the last of it there is a parameter list, there is a function. Okay, so it is a special function. We can say it is a function template, or it will work as like a constructor also, because it will allocate the memory and it will create the object. Okay, so by using this complete syntax, you can create the unique pointer and you can allocate the memory to each of. Okay, so one more time we'll see that standard is the namespace, scope resolution operator, unique pointer because this unique pointer belongs to std namespace, followed by type of that unique pointer, whether it may be your integer, float, character, etc. Followed by the object name, okay, equal to, then again standard and make unique. Make unique is the name of your function template. Okay, again data type and parameter. Okay. STD unique PTR cannot be. Okay, what is it? It is a transferring ownership. Now, in the last example, we have seen that how can we create the smart pointer. But it has one more feature that, as we said, that only at a single time you can have a only one unique pointer and or a unique pointer can occupy the resource and no other pointer can occupy the same resource. Another one important thing about the unique pointer is what? The unique pointer cannot be copied. Means like this. If suppose you have created one unique pointer in the earlier example like this, whose name is p1, and if you are trying that, if you are creating another pointer like this, standard unique ptr t p2 is equal to p1, so it means that you are trying to assign this p1 unique pointer to this another unique pointer that is p2, so that will not be allowed because your unique pointer cannot be copied. Your unique pointer cannot be copied, but it can be moved. Means you can transfer the ownership of one unique pointer to the another. You cannot copy that, but you can directly move the ownership. You can transfer the ownership of that object or the smart pointer to another smart pointer. So in that case, what happens? If your unique pointer, if you have created this p1 and you are trying to move like this by using this syntax std colon colon move and p1, it means that you are transferring the ownership of p1 to p2. In that case, once the ownership is transferred, then this p1 will be destroyed. Why? Because we have already said that a unique pointer can own only one unique pointer can own the given object at a time. It means that whatever the resources it has been occupied by P1, the ownership of that resource will be transferred to this P2. So this P1 will go to the out of the scope, or we can say that it will be destroyed. So whenever you are using unique pointer, the first point to be remember over here that it can have or the whenever unique pointer will be used, then it will have the complete ownership of that object. Second important thing about unique pointer is what? That you cannot copy the pointer to another. Instead, you can transfer the ownership, like by using this move keyword. Okay. Now let's see the example. Here in this case, we have included IO stream, we have included memory also using namespace std. Now we have created one class named as animal. Okay. In that animal class, we are having one constructor named as animal, and that will print the animal constructor code. Similarly, it is having one destructor which will, when it will execute, then it will call the animal destructor code. Okay, so in this animal class, we are having animal constructor, animal destructor, and one method which we have declared as a virtual. Okay, it means that we are going to derive this. We are going to derive the. We are going to create a new derived class from this animal class, and within which we are going to override this method speak. Okay, so whenever we will redefine, then we will write something else. But now in the animal class, we have we are printing the animal name sound. Okay, so whenever this function will invoke, it will execute this and it will print the animal name sound. Okay, this is my simple class in which there is one constructor, one destructor, and one function named as speak. Getting my point? Now, from this animal class, we are creating another class named as dog. So class dog inheriting this animal class public animal, and in this dog class also there is one constructor. Let's say this is the dog, it is a constructor in which we are printing dog constructor called. There is one destructor and which will print dog destructor called when it will execute. And now here we are redefining the method speak over it, right? So while redefining, we are using override keyword and we are printing say dog says food. So now in the dog class, we are inheriting the animal class, and in that also it is having its own constructor, its own destructor, and we are redefining or overriding the speak method which is already defined in the base class. Okay. From this animal class, we are again creating the third class named as cat. Okay. See here, we are publicly inheriting this animal class within this cat class. This cat class is also having its own constructor, which is printing cat constructor called, which is having one another destructor, which is printing like destructor called, cat destructor called. And again, we are redefining this speak method. We are overriding this speak method from the animal class, and here we are printing cat says meow. So now the structure of our classes is we are having one animal class which is having animal constructor, animal destructor, and one speak method. From this animal class, we have created two separate classes. One is dog and one is cat. Both the classes is having their own constructor, their own destructor, and we are overriding the method speak method in both the classes. But every time it is printing something different. In the dog class, it is printing dog says woof. In the cat class, it is printing the cat says meow. And in the base class animal, it is printing like animal makes sound. Okay. So just let's copy this program so we'll have a clear understanding of this program. So now let us understand this. First, we have created animal class, which is having animal constructor, animal destructor, and one speak method. After that, we have created dog class, which is also having its own constructor, which is having one destructor. After that, speak method. We are overriding the speak method. Also, we have created the cat class, which is having cat constructor, which is having cat destructor also, and one speak method. Okay. So now the speak method is visible in three times. Okay. One in the animal class, one in the dog class, and one in the one in the cat class. Okay. So now in the main function, now let us take what we did. So first it will print that unique pointer example, and here we have created the unique pointer of type animal. Okay, because we are creating the object, so we are assigning the animal type. Means base class pointer we are creating over here basically. So we are creating the base class unique pointer. So therefore we have provided the name of our base class. The name of our pointer is dog_ptr, and to create the object we are creating the make unique and dog. Now here see 2 points to check over here that we have not used std before this like this std colon. Why? Because we have already included that std at the top of our program, that is the using namespace std. Right. Second important point to be remember over here, that to be focused over here, that while we are declaring the pointer, then we have used the base class, and while we are assigning the reference, then we have used the derived class. So it means that similar to our pointer concept, we have created the base class pointer, but that pointer is not a simple raw pointer. It is a smart unique pointer. Okay. So we have created the base class type or the base class unique pointer. At the same time, we are assigning it to a reference of our dog class, right? So this will create, this complete syntax will create the dog pointer or the, we can say the smart pointer, unique pointer, which will hold the reference of your dog class, right? So when we use this base class pointer and call the speak method, then first it will check that whose reference it is currently holding. So now in that case, as this dog pointer is holding the reference of this dog class, so when we execute or when we try to call this speak method by using this pointer, then definitely it will execute the speak method which belongs to the which class? Dog class. Okay. Now see the output as we have executed this program. So whenever this statement has executed that I have highlighted, unique pointer animal doc ptr make unique doc. So whenever I have created the doc pointer of the base class, so then it has invoked. See, we are assigning the reference of our doc class, right? So my doc class is also having the constructor, and my base class is also having the constructor. And we know that in which manner our constructor will be invoked. We have already learned that concept in the concept of inheritance, that if your base class and derived class, both the classes is having the constructor, and if you are creating the object of your derived class, then also the first constructor that will be invoked which belongs to the base class. So whenever we are creating, in this case also we are creating the object, okay, even though we have created object of our base class and we are assigning the object of your derived class, then also it will first invoke the base class constructor, so it has printed the animal constructor called. After this constructor will be invoked, it will call the derived class constructor. So now the derived class is what? Dog. So it has executed the dog constructor call, right? After that, once this line has been finished, then it jumps to the second line. And by using this pointer, when we try to call the speak function, then it will definitely call the speak method which belongs to the dog class. So in the dog class, within this speak method, we have written the dog says who. So it has printed the dog says who. Okay. Now, point to be remember over there, this unique pointer is owning or is having the ownership of your dog class right now, right? So therefore, this object will hold the reference of your dog class, and it is owning the object or it is owning that class. After that, what we did, we have created one another pointer, unique pointer animal, another dog. Okay. Now another dog, and also we are moving the ownership over here. See, by using this move function, we are transferring the ownership of this dog pointer. Okay. So now initially this dog pointer is owning this dog class. So this ownership will be transferred to this another dog. So when the ownership has been transferred, so it means that by this dog pointer, base class unique pointer will be destroyed. Okay. And to check that, we have used one condition over here, that if not dog pointer, it means that this dog pointer is destroyed, then print this statement, that is the dog print ptr no longer owns the object. Okay. Once this dog pointer destroyed, then sorry, here dog pointer no longer owns the object. It means that as soon as we have transfer the ownership of this dog ptr, then this dog ptr will be destroyed. And to check that, we have checked this condition whether it is really destroyed or not, and it is destroyed. Therefore, it has executed this statement, that is the dog ptr no longer owns the object. But now the ownership of this dog class will be assigned to this another object, that is the another dog, right? So therefore, if we call this another speak method by using this another dog, then again it will call this dog says who. Why? Because now this another dog is having the ownership of your dog class, or we can simply say that this another dog is having the reference of your dog class. So by using this reference, you can call this speak method. So again, it will print that dog says who. Now at last, when it reached to the return 0, it means that my uh, program is ended over here. So in that case, it will call the destructor of all the classes. And we know the in which manner our destructor will be invoked. Basically, the last object that you have created of that class, so that destructor will be invoked first. So we have created the object of our dog class. So therefore, it will first call the destructor of this dog class. So it will print dog destructor called. And as this dog class is having the base class, that is animal class, so the program control transfers to your base class, and it will call the animal destructor called, or it will execute the destructor which belongs to the animal class. Okay. So simply here, what we did in the main function, we have created the unique pointer first. We have assigned the reference of our dog class. So now it means that this dog pointer owns this dog class, and by using this pointer, if we call the speak method, then it will execute the speak method which belongs to the dog class. So it has printed dog state root. After that, we have transferred the ownership of this dog ptr to the another dog. It means that initially dog ptr will hold the reference of dog class. Now another dog will hold the reference of your dog class, and at the same time this doc preparer will be destroyed. So therefore, if we check this, then it will execute this statement and it will print that doc preparer no longer used. At last, we have called the speak method again by using the another doc. So it will again execute the speak method which belongs to the doc class and it will print doc says who. And last, when our program is going to end, then at that time it will call all the destructor. First, it will execute the destructor belongs to the doc class. After that, it will execute the destructor which belongs to the animal class. Right. So this is the concept of unique pointer. Okay. If you are having any doubt, you can ask me. I think we have very limited time right now. And I hope we have to stop over here. We'll complete the remaining part in the next session because there are again some concepts like share pointer and big pointer also and multi-threading also. So if you are having any doubt, you can ask me. Did you understand this
Learners,
concept?
any doubt you can ask.
Did you understand this concept? Unique pointer, smart pointer. See here, we have not used any new keyword. We have not used delete keyword over here. Why? Because we are using the smart pointer, so we don't have to manually allocate the memory as well as we don't have to uh, delete the memory, clear of the memory, right? So that is the main advantage of using the smart pointers. And one important point about unique pointer is what? Whenever it will acquire any resource, then no other pointer can acquire that resources, right? Well, you cannot copy that pointer also. If you want to transfer the ownership, then you can transfer the ownership by using the move function. But at the same time, your initial smart pointer will be destroyed. Getting my point? So keep this in mind. We'll meet in the next session and where we will complete the remaining part. Okay, tomorrow. So can we conclude this session?
I think, sir, learners are not having any doubt. Yes, we can conclude this session. And thank you so much, Shasta, for conducting this session. And dear learners, thanks for joining. Good night, everyone. Take care.